Hi guys, today we gonna study about the design procedure of the canal by Kennedy's method. So we have already studied the laces design steps of the canal. In this method, first step we will calculate the critical velocity by using the Kennedy's equation, which critical velocity is equal to 0.55 my power 0.64, where y will be the trial value depth will be calculated in the last step. In the second step, we will determine the area, so that we have q is equal to a v naught, which is the critical velocity. So area will be q times q divided v naught. In the third step, we will determine the channel cross section, that will be the area and the perimeter. And we know that for the trapezoidal sections, area is equal to by plus zy square, whereas perimeter equal to base plus 2 times of y root under 1 plus z square. By calculating the area and perimeter, in the fourth step we will calculate the actual mean velocity v. In the Kutal formula, we have actual velocity is equal to this formula, which we must need to remember for the numerical part. Now from the Manning formula, we have mean velocity is equal to 1 by n, r power 2 by 3 and s power 1 by 2, whereas n is the ruggedity coefficient, r is the hydraulic mean depth, and s is the bed slope. From the Chase's formula, we have v is equal to c root under rs, where c is the Chase's constant. After calculating all these, we have to calculate for the depth. So for that, we will assume the depth value, which we will keep on repeating until we get v naught is equal to v, that will be the critical velocity is equal to mean velocity. When the critical velocity will be equal to the mean velocity, that respective depth will be our answer. Now we will do a numerical based on the Kennedy's method of the design step of canal. Given question, we have canal using the Kennedy formula with the following data, so that given what is given is here given discharge is equal to 40 cubics, Manning's roughness coefficient n is equal to 0.018, and the bed slope is equal to 0.00020, whereas the side slope z is to 1 is equal to 0.5 is to 1. From the design stage of the Kennedys, we have for the first step, we have critical velocity is equal to 0.55 my power 0.64, m is equal to 1, which is equal to 0.55 times 1 into y to the power 0.64, that will be equal to 0.55 y to power 0.64. In the second step, we will calculate the area of the channel, which will be equal to q divided by v naught. So discharge is given as 40. In the third step, we will determine the cross section of the channel, which is the area and the perimeter. So for a trapezoidal section, we have area is equal to by plus zy square. B is equal to a minus zy square divided by y. Value of z is 0.5, so we have a minus 0.5 times of y square divided by y. Also from the perimeter, we have p is equal to b plus 2y root under 1 plus z square, which is equal to b plus 2 times of y root under 1 plus 0.5 times of square, which is b plus y root under 5. R is equal to a by perimeter. So in the fifth step, we will calculate for the mean velocity. So from the, since the value of the Manning's ruggedity is given, coefficient is given, so we will calculate the mean velocity from the Manning's equation, which will be equal to v is equal to 1 by n, r to power 2 by 3 and s power 1 by 2. 1 by 0.018 into 0.00020 power 1 by 2. assume y is equal to 1 meter. We'll make a table here. This will be the trial number. This will be y, then v naught, a, b, p, the hydraulic mean depth, mean velocity, and the remarks. For the remarks, if critical velocity is less than the mean depth, then increase y, and if the v naught is greater than v, then decrease y. For this, we will make our equation on the calculator. This will be y is to, we will assume this as x, so that y is to x is equal to 0.55 y to power 0.64. Since that this will be a is equal to 40 divided by x, b will be equal to, this b will be equal to a minus 0.5 times of y square divided by y. Then we will assume p as c, which will be equal to b plus y root under 5. Then we will assume r as d, which will be equal to a by p. That will be a by p we have assumed as c. Then this mean velocity will be assumed as e, which will be equal to 0.785 times r2 by 3. Calculator y colon x equal to 0.55 times y to power 0.64, which colon a equal to 40 by x, colon b equal to a minus 0.5 y square by y, colon c equal to b plus y root under 5, colon d equal to a by c, colon a equal to 0.75 r what is it, I, a, b, c, d, d to power 2 by 3. So now calculate y we have the depth equal to 2 meters, y as 2, x as 0.85, a as 46.67, b is equal to 22.33. This perimeter is 26.80, hydraulic mean depth is 1.74, mean velocity is 1.13. Again, the critical velocity and the mean velocity is not equal to v. Since this critical velocity is less than the mean velocity, therefore we will increase the y. So in the fourth step, 2.5, putting the value of y as, assuming the value of y as 2.5. So 2.5 is equal to, we get the critical velocity as 0.98, 40.45, 14.93, 20.52, 1.97, 1.23. Again here the v naught is not equal to v, so we will increase the value of y, that will be 3. For the depth 3 meter, we have v naught as 1.11, 36.003, 10.50, 17.20, 2.09, 1.28. v naught is not equal to v. In the trial number 6, we will increase the depth value as 3.5. So for 3.5, 1.22 equals to 32.62, 7.57, 15.39, 2.11, 1.29. That is not equal to v. So the value of v naught and the value of v is nearly equals to. So now we will increase the value for only 2. For 3.7 we get 1.27, 31.48, 6.65, 14.93, 2.10, 1.29. Here also v naught is not equal to v. For 3.8 we will check now, as these are nearly equals to. So for 3.8, 1.29, 30.94, 6.24, 14.74, 2.09, 1.2. The v naught is equal to v. So we get the value of the y as 3.8 meter. So this will be the answer. So that's all for the today's video. We will solve more numerical in the upcoming videos of this design of canals chapter. If you guys have any confusion, then you guys can just comment in the comment box below. I will see you guys in the next video. Thank you.